Have you ever wondered about the enigma of a cat being alive and dead? Welcome to the world of Erwin Schrödinger's theoretical concept, Schrödinger's cat. What's a theoretical concept, you ask? It's an idea that's not yet verified, but stimulates further study or discussion. Now, Schrödinger's cat is not an actual experiment, but it's born out of Schrödinger's imagination. It's purely theoretical, a construct of his mind devised to illustrate the peculiarities of quantum mechanics. But what is quantum mechanics? It's a branch of physics dealing with the behavior of particles at the atomic and subatomic levels. This thought experiment showcases one of the most intriguing aspects of quantum mechanics, the superposition principle. This principle states that a particle can exist in multiple states simultaneously, according to quantum mechanics. Our everyday understanding of reality is primarily based on what our senses can directly take in, which brings us to the perception problem. The perception problem refers to the limitations of our senses in fully grasping and comprehending the complexity of the world. Our senses primarily access a fraction of this complexity, which is the macroscopic world isn't well calibrated to perceive the tiny particles of quantum mechanics. To elaborate, quantum particles are the tiniest units of matter, even smaller than atoms. As a result, we struggle concept of quantum reality. In our observable macro world, objects have a definite state. Yet, quantum particles exist in a unique phenomenon known as superposition states. These superposition states refer to the ability of quantum particles to exist in multiple states at once until they are observed, a concept illustrated by Schrödinger's cat experiment. The perception problem is a captivating that not only challenges our understanding of reality, but also of the quantum world. It adds another layer to the Schrödinger's cat experiment, creating the perfect segue into our expropriation, the experiment in the sealed box. Let's imagine this scenario. A cat is situated inside a box with a radioactive substance. This substance holds the potential to decay, subsequently igniting a mechanism that releases poison, which may potentially kill the cat. The viewpoint of classical physics, which operates on the laws of physics as we understand them in the macroscopic world, dictates that the cat is in one definitive state, either alive or dead. However, quantum mechanics, a branch of physics that deals with the behavior of particles on the atomic and subatomic levels, presents a counter-argument. It proposes that until we lift the box lid and make an observation, the cat dwells in a superposition state. In simpler terms, it implies that the cat is simultaneously dead. It's only when we decide to observe the cat that this superposition collapses, resulting in one of the two possible outcomes. The cat is either alive or dead. Before we delve deeper into the enigma of Schrödinger's cat, we must make a detour to familiarize ourselves with a significant concept in quantum mechanics, the double-slit experiment. This experiment, a fundamental cornerstone in quantum physics, is a famous demonstration that particles can exhibit wave-like and particle-like characteristics, known as wave-particle duality. Imagine a screen with two slits, and we fire particles at it. When we don't observe which slit the particle passes through, an interference pattern emerges on the detection screen behind, similar to the pattern waves would produce. This implies that particles, in this case, are acting like waves, a phenomenon central to the concept of wave-particle duality. However, the moment we decide to observe which slit the particle passes through, the interference pattern vanishes and we see two bars on the detection screen. This indicates that particles behave just like, well, particles. This shift is not a mere coincidence but a direct consequence of observation, illustrating the collapse of the wave function, the same principle that underpins the paradox of Schrödinger's cat. Thus, the experiment is not just an experiment but a vivid representation of the wave-particle duality, highlighting how observation can alter the outcome in the quantum world and laying the groundwork for the puzzle of Schrödinger's cat. This leads us to a widespread misconception about Schrödinger's cat. The misconception refers to a misunderstanding or incorrect belief is that many think it asserts that conscious observers shape reality. However, Schrödinger never intended such a misinterpretation. Instead, his paradox shed light on the measurement problem in quantum physics. This measurement problem refers to the change in a quantum system when it is observed. It seeks to understand how the quantum superposition, which allows particles to exist in multiple states simultaneously, results in specific outcomes in the tangible macro world. Therefore, Schrödinger's cat essentially serves as a tool to demonstrate the discrepancy between quantum mechanics and our everyday experiences. To summarize, Schrödinger's cat is not an actual experiment, nor does it imply that observers shape reality. It's a thought experiment, which essentially means it's an experiment carried out purely within the mind, not in a physical laboratory. It serves as a metaphor that presents the peculiar characteristics of quantum mechanics. In essence, Schrödinger crafted this ideology to demonstrate the concept of quantum superposition, a term that might sound complicated, but it's just about the ability of particles to exist in multiple states at once. It's like the particle is in all possible positions at the same time until observed. This idea fundamentally contradicts our everyday reality, where things seemingly exist in one state at a time. Through the lens of this thought experiment, it becomes possible to underscore the importance of more profound insight into how quantum superposition transitions into the macroscopic reality we experience. Quantum physics, the branch of physics that deals with the behavior of particles at the atomic and subatomic levels, is as captivating as it is intricate. This world is alive with notions that can often confound our customary interpretation of reality. Consider, for instance, Schrödinger's cat. This thought experiment, seeming to dance on the fringes of the ridiculous, presents us with strange and unusual concepts, the so-called bizarre ideas that challenge and stretch our understanding. Far from being cast aside as mere flights of fancy, these bizarre ideas, those that seem strange or unusual, play an essential role in our quest for knowledge. They push us to question the known, motivating us to probe more intently into the universe's enigmas. These seemingly outlandish ideas demonstrate that sometimes the most peculiar theories can expand the limits of our comprehension and inspire us to explore further into the universe's many mysteries. And before we wrap up, if you've cherished this voyage into the realm of quantum physics, remember to give us a thumbs up and subscribe. Your support aids us in generating further content about intriguing subjects, from the enigmas of the cosmos to the minutest particles. Quantum physics exploration, to elaborate, refers to the study and investigation of the principles of quantum physics. We strive to simplify intricate concepts, making the realm of science accessible to all. Our next episode features an exploration of Schrödinger's cat, a thought experiment in quantum mechanics that brilliantly illustrates the concept of superposition. We are thrilled to share this enlightening journey with you. Until we meet again, keep probing, discovering, questioning, and broadening your horizons.